Welcome to Geometry. This is Mr. O'Shea. Today we're going to be covering section 2.5, which is essentially proving angles congruent. We're going to use a lot of the stuff we've talked about in class for the past couple of days, complementary, supplementary, vertical angles, and how we can actually kind of use those to our advantage now. So another theorem for you, theorem 2-1. It states that very simply, vertical angles are congruent. And some of you guys notice this in the research that you've done. Vertical angles are congruent. Remember, vertical angles are formed when two lines intersect, and it's the opposite angles. So we've got the one on the left and the one on the right. They are congruent, as well as the one on the top and the one on the bottom are congruent as well. So if the bottom is 100, the top is 100, which means the left is 80 and the right is also 80. All right, if we want to solve for x, we've got some vertical angles here, and I know that opposite angles are congruent in the vertical angle. So 4x can really equal 3x plus 35. Subtract 3x from both sides. Let's go ahead and solve this through. Subtract 3x here, and I'm left with 1x equals 35, which just means x equals 35. Again, we got this based on the fact that vertical angles are congruent, so our angle on the left has to be equal to the angle on the right. Theorem 2-2. This one's going to be called the congruent supplements theorem, and all it states is that if two angles are supplements remember, supplementary is adding up to 180. If two angles are supplementary to the same angle, then the two angles are congruent. If two angles are supplementary to the same angle, then those two angles are congruent. And we'll do a little example here that kind of proves that point. So if we have angle 1 and angle 2 are supplementary, angle 3 and angle 2 are supplementary, the conclusion we can draw is that angle 1 is congruent to angle 3. Let's go ahead and do that real quick. Angle 1 plus angle 2 has the equal 180 because they are supplementary. And angle 3 plus angle 2 also has to equal 180 because those are supplementary as well. Let's just assign some values here. I'm just going to make up some values. Let's say angle 1 plus, I don't know, we'll go with 30 degrees for angle 2. That has the equal 180. I just picked 30 for angle 2. But if it was angle 2 was 30 degrees in the first one, it also has to be 30 degrees in the second one. So something plus 30 is 180. Something plus 30 is 180. Obviously, that's 150. Angle 1 is 150. Angle 3 is also 150. So because they were supplementary to the same angle at 30 degrees, we know that those two angles are indeed congruent. Angle 1 is congruent to angle 3. Congruent complements theorem, theorem 2-3. It's very similar. It's just going to be the complements. If two angles are complementary, oh, you know what? Spelled that a little wrong there. There's no I. Complements, if two angles are complements of the same angle, then those two angles are congruent. If two angles are complements of the same thing, then those two angles are congruent. Similar to that last example that we just proved, right? Instead of 180, though, if they're complements, they're going to be 90 degrees. So we could say 90. That would mean that that's 90, and this is 90. which changes it. I mean, it still is going to mean angle 1 and angle 3 are the same angle because they're complements to angle 2. That just turns it into 60 because 60 plus 30 would give us the 90. And again, we still come up with the same conclusion that angle 1 is congruent to angle 3. All right, theorem 2-4. 2-4. This is very simply stated. All, important, all right angles are congruent. All right angles are congruent. No matter where that right angle is, it's always going to be congruent to all other right angles. Theorem 2-5. If two angles, abbreviate that one, if two angles are congruent and the two angles are supplementary, so if they're congruent and supplementary, then each angle is a right angle. This one makes a little bit more sense if we actually see a picture of it. So a straight line here, and two angles are supplementary and congruent. So if this angle is congruent to this angle and they're supplementary, they have to add up to 180. The only two numbers that are going to make that work are 90 and 90. If it's 90 degrees, that means it's a right angle. If two angles are congruent and supplementary, each angle has to be a 90-degree angle. Now we've done a lot of theorems in this one. You've got 2-1, 2-2, 2-3, 2-4, 2-5. Theorems are great, and if we prove them together, you don't have to prove them again. So when I ask you guys to prove something in class, you no longer have to prove these theorems because we're actually given that they are proven to us already. All right, I want to know an angle that's supplementary to AOD. So we've got AOD that I'm highlighting here in blue. We need one that's supplementary, so it has to add up to 180 degrees. You can also think of it as kind of which ones add up to a straight line. So I see that one right there. Angle, call that one angle DOC. That would add up to 180 degrees with that first given angle. That's not the only one though. We also have right in here, angle BOA. Angle BOA. It might help if we actually, let's go ahead and erase some of this stuff. Sometimes it's easier to kind of get rid of all the clutter to help us see something. So we had angle AOD, we also have angle BOA. That's how we can kind of visualize that one a little bit more. So I need adjacent and congruent to AOE. So I've got angle AOE right in here. AOE, right in the purple. I need adjacent and congruent. So it has to be next to it, and it has to also be 90 degrees. That one's adjacent, but it's not congruent, so that doesn't work. That one there is adjacent, but it's only 60 degrees, so that doesn't work either. So you might be thinking that this is impossible. But if we've got AOE, which is 90 degrees, you also have another angle that's 90 degrees, angle EOC. The bigger angle is 90 degrees. So adjacent and congruent would be angle EOC. Supplementary to EOA. Supplementary to EOA. We've got angle BOA. No, that's not going to work because that's not the full line. There we go. Angle EOC. Those two angles added together make the straight line. So that's going to be angle EOC. Please note on these, you guys, it is not angle EOD and DOC. Like, you can't add those two angles together and say, hey, if we add those two, then they're supplementary. Because when we're talking about supplementary, we're talking about pairs of angles. You can only have two angles. Complementary to EOD. Well, it's going to be the angle right next to it. Those two angles would add up to a total of 90 degrees. So we've got those two, which is going to be angle COD. COD. Pairs of vertical angles. Remember, vertical angles stem from two lines that intersect and form opposite angles. So we've got the only two lines that completely intersect are those two lines there, and highlighted in blue. The opposite angles are vertical angles. So you've got that angle and the opposite one from it. So we could say angle BOA is congruent to, remember, vertical angles are congruent, angle COD, the top and the bottom. You've also got this one in green here, angle BOC, and the one on the right, angle AOD. Sometimes, again, like I said, guys, it helps to kind of clear up the clutter that you have. And if you want to get rid of it as much as possible, just so you really are visualizing those vertical angles, get rid of everything else that's in the diagram. Now you can very easily see, oh, it is BOC and AOD. All right, solve for x and y with the vertical angle idea going. Remember, we said opposite angles are congruent when we're dealing with vertical angles. So 3x equals 80 minus x. Solve this, we're going to quickly add x to both sides to cancel those. So we're left with 4x equals 80. Divide each side by 4. And we're left with the answer of x equals 20. Piece of cake. Another one here. We've got 3x, we've got y, and 75. Now this is kind of a trickier one here. Some people are tempted to say, oh, I know, it's 3x plus y equals 180. But that doesn't help us just yet. We need to figure out one of those angles. We know one. 3x, that's congruent to 75. So to solve for x, I'm just going to say, well, 3x equals 75. They're congruent, they're vertical. Divide each side by 3. You get x equals 25. Now to solve for y, we've got to kind of approach it a little slightly different. We don't have the vertical angle of it. We don't have the one down on the bottom of y. But we do know that y plus 75 is 180. Those two are supplementary. So y plus 75 equals 180. Subtract 75 on both sides. And we're left with the fact that y equals 105. X plus 90 and 4x. So that's going to be x plus 90 equals 4x. Vertical angles are congruent. Subtract x on both sides. The x's cancel, and I'm left with 90 equals 3x. Divide each side by 3, and we're left with a finalized answer of x equals 30. Sometimes you're given extra information that you do not need. Please just use what's pertinent to us, guys. Vertical angles are congruent is the main idea of this specific lesson. See you guys in class.